We are entering a new phase of computing. For the last decade, the center of gravity has been the cloud. Massive data centers run by a handful of giant companies did all the heavy lifting. Our phones and laptops were often just elegant windows into that immense power. Now that's starting to change. Two powerful forces are pulling intelligence out of the cloud and putting it directly into our hands, into our cars, onto our faces. The first force is speed, the second is privacy. Making a decision in a distant data center takes time, and sending our personal data there creates risk. This is the core proposition of Edge AI. Edge AI is simply artificial intelligence that runs locally on a device. It does not need a constant connection to a massive server farm hundreds of miles away to think. The computation happens right there, on the chip inside your phone, your security camera, your smartwatch. This is a fundamental architectural shift. It moves the brain of the operation from a centralized remote location to the decentralized edge of the network, where the data is actually created and needed. This proximity is what unlocks its most compelling advantages, creating experiences that feel instantaneous and personal, rather than remote and generic. So, what does Edge AI actually look like in the wild? It is not some far-off theoretical concept, it is already embedded in many of the devices we use every single day. The key is that the AI models are specially designed and compressed to run efficiently on small, power-constrained hardware. They are optimized for performance, not for sheer scale. This allows them to deliver sophisticated results without draining your battery or requiring a supercomputer. This is a crucial engineering feat, turning massive, power-hungry algorithms into something that can run silently in your pocket. Consider the modern smartphone camera. When you point it at a group of people, it instantly identifies faces. It adjusts the focus for each one. It balances the lighting to ensure everyone looks their best. This is Edge AI at work. Facial recognition, scene detection, image enhancement are all running directly on the phone's processor in real time. The device isn't sending a video stream to the cloud and waiting for instructions. It is making thousands of calculations per second on its own, which is why the experience feels so fluid and responsive. Another powerful example is the smart security camera. Older models would simply record everything and send it to the cloud, consuming vast amounts of bandwidth and storage. A camera with Edge AI is much smarter. It can analyze the video feed locally to differentiate between a person, a passing car, a swaying tree branch. It only sends you a notification and a short clip when something truly relevant happens, like a package delivery. This saves data, reduces false alarms, and means hours of footage aren't being stored on a remote server. A smartwatch uses Edge AI to constantly monitor your biometrics. It can track your heart rate, analyze your sleep patterns, detect a sudden fall. Because this analysis happens on the watch itself, it can react instantly, perhaps vibrating to wake you from a bad dream, or automatically calling for help after a fall, even if it is not connected to your phone or the internet. It is important to understand that Edge AI is not a direct replacement for Cloud AI. Instead, they are two different tools for two different kinds of jobs. Thinking of it as a competition is the wrong framing. A better analogy is a workshop. Cloud AI is the massive, stationary, industrial press in the corner. It requires enormous power and infrastructure, but it can perform immense tasks that are impossible for anything else. It is perfect for training enormous new AI models on petabytes of data, or conducting deep scientific research that takes weeks to run. Edge AI, in contrast, is the powerful portable cordless drill. It is designed for speed, agility, working on site. It runs on a small battery and can be used anywhere, delivering immediate results right where you need them, not to reshape a 2-ton block of steel, but to quickly and precisely perform a specific task in the real world. This is what it excels at: quick, local, context-aware computation. The primary difference comes down to resources. The cloud has access to virtually infinite computing power, storage, and electricity. It can run AI models with hundreds of billions of parameters. This is why a large language model chatbot lives in the cloud. No phone could possibly hold or process that much information. The cloud is for tasks of encyclopedic scope and scale. Edge AI operates under tight thermal, memory, and battery limitations. The models must be small and ruthlessly efficient, often specialized, like wake word detection or identifying a cat, while a cloud model might write a sonnet and compose a song. The advantages of this local approach are compelling and are driving its adoption across industries. The most obvious benefit is speed, low latency. By eliminating the round trip to a data center, Edge AI enables responses in milliseconds. For autonomous vehicles, augmented reality glasses, and responsive gaming, any delay can ruin the experience or be dangerous. The second major benefit is privacy and security. Keeping data on the device is the simplest and most robust way to protect it. No raw personal data in transit, no central database to breach. Companies can offer intelligent features without becoming custodians of sensitive information, a model that builds trust and aligns with data sovereignty. It puts the user back in control. Reliability improves too. Apps keep working with spotty or no internet, in remote areas, on airplanes, during outages. Processing at the edge slashes cloud compute and data transfer fees. At scale, savings are monumental, shifting costs from recurring OpEx to one-time hardware. Yet there are limitations. Smaller models can be less accurate. Devices have finite memory and compute. Managing updates across millions of diverse devices is challenging. And a physically compromised device presents a different security risk. The path forward is not a binary choice between the edge and the cloud. The most powerful systems will use both in a symbiotic relationship. The cloud remains the brain factory, training and refining massive models, then compressing and optimizing them for deployment to edge devices. The device handles real-time, privacy-sensitive tasks, performs autonomously, gives instant feedback, and keeps personal data local, forming a virtuous improvement cycle via federated learning. Think of it in action. Your phone's keyboard AI running on device learns your slang and typing patterns to offer better suggestions. Periodically, those localized learnings are anonymized and sent to the cloud as part of updates. The cloud aggregates insights from millions of users and improves the central model, then pushes that improved model back down in the next software update. You get a smarter keyboard, and your private messages never leave your device. This fusion is the blueprint for future intelligent systems. As device chips get more powerful and model optimization tools improve, more intelligence migrates to the edge. This won't make the cloud obsolete. It frees the cloud to focus on large-scale problems. The edge handles the immediate present. The cloud builds a better future. A world of devices that are connected and truly, personally intelligent. Edge AI is making our technology faster, more private, more reliable. Intelligence where you are, on your device, so the future can respond in real time.